Hello. Good morning, everyone. Happy Wednesday. Yeah. Today we're going to talk about parallel lines. Okay. Now we did not dip over to geometry class, which is what you might think. Um, Parallel lines have something very unique that makes them important to us, especially in algebra. So, um, if you have a graphing calculator, okay. Which I don't know if you guys do or not, but if you do, or if you go to the Desmos calculator, so on your Chromebook or whatever, go to Desmos, just search Desmos calculator, it's a graphing calculator. You can type in these equations, they'll graph the lines for you. But if we looked at y equals 2x minus 7, and y equals 2x plus 3, and y equals 2x plus 9. Right? Those equations, those are all equations of lines. And if you have a graphing calculator, if you hit y equals in the top left corner, you can input these equations into the different lines. And then when you're ready to graph, just hit zoom 6. Or if you go to Desmos, you can just type these in. Y equals 2x minus 7, y equals 2x plus 3, y equals 2x plus 9. And you'll see these different lines. But what do these three lines have in common? And hopefully, you guys can tell, just by looking at them, they all have the same slope. So, if you were to graph these three, which hopefully you're doing on Desmos or on your graphing calculator, you'll see that these lines are all parallel lines. And the reason why they are is because all lines that have the same slope are parallel to each other. Now, in case you guys forget what it means to be parallel, two lines are parallel if they will never ever intersect each other. So let's talk a little bit here. If you want to think about why that's true, slope is how a line moves. And so if I don't ever want lines to cross each other, we know that their slope is how much they rise and how much they run. So, for example, if we started here, and let's say we had a slope of 1/3. So we go up 1 over 3, up 1 over 3, 1, 2, 3. All right, so we have this line. That's about y, whatever. Y equals 1/3 x plus 2. Now, if I graphed, let's pretend like it's a little bit more straight. Okay. Now, if I graph something like y equals 1/3 x minus 4, it's going to start down here. But notice that the line is going to change at the same rate, right? We call slope rate of change. So it's going to go up 1 over 3, up 1 over 3. There we go. Back 1, 1, 2, 3. So even though my graph is pretty shoddy and my lines aren't very straight, you can tell that those lines are going to be like parallel lines because they have the same slope. And so that's kind of a cool thing. We know that lines will never intersect if they have the same slope. And in fact, if you remember when we solved equations earlier and we talked about this idea of no solution, that would be the case where two sides of the equation, if we graphed both sides, they would be parallel lines. So no solution actually means that they don't ever intersect each other. There's no place where they would be equal. They're always going to be going at the same rate, so they'll never be equal to each other, which is kind of a really cool idea. In fact, if I gave you an equation like 3x minus 4 equals 3x plus 1. You can probably tell that that's going to be a no solution, right? If I subtract the 3x from both sides, you get different numbers. But literally, if you thought about graphing this side and then graphing this side, you'll see that the reason why you get no solution is they're actually parallel lines. It's kind of cool. So, what are we going to do with that information? Well, mostly, you just have to know that parallel lines have the same slope. So, for example, let's say I gave you, hey, there's this line, y equals 3x minus 7, and I want a line that's parallel to this line, but it goes through the point -3, -8. All right, so I want a line that is parallel to that line, but I want it to go through a specific point. So here's what we're going to do. We can come up with that line, but from this line, we have to make sure that we take what we need, which is the slope here, right? So I know if they're parallel, they have the same slope. So what I'm really asking is, I want an equation of a line with a slope of 3 that goes through -3, -8. And if that looks familiar, that's good because we already did that, right? When we talked about slope-intercept form last week, we can actually figure this out. So we're going to use y equals mx plus b. Or I guess you could use point-slope form, now that you know about point-slope form if you want. Slope-intercept form is way better, but yeah, whatever. And then we're just going to plug in. So my y value is -8. My slope is 3. My x value is -3. We don't know b. 3 times -3 is -9. And then we're going to add 9 to both sides. And I can see that b is going to be +1. So my equation y equals 3x plus 1 is parallel to this line that we started with, but it goes through the point -3, -8. Cool, huh? Yeah. Let's rock one more of those out. I only gave you a couple problems today. Tomorrow we're going to talk about what it means to be perpendicular, and then we're going to kind of put a spin on this type of problem, and then we have a little bit more options for what kind of problems we're going to see. So let's say we have an equation, y equals -2/3 x minus 77. And I want a line parallel to this one, but goes through the point 9, that doesn't look like a 9, 9, 22. All right, so the fact that it's parallel means that they're going to have the same slope. So I'm going to take the slope from the equation they gave me, and then I know it goes through 9 too. So we're going to start with slope-intercept form. And we're going to go ahead and plug in. So the y value is 22. My slope here is -2/3. The x value is 9. And we don't know b. Do a little bit of math. -2/3 times 9. If you don't have a calculator or something, just go straight across. -2 times 9 is -18. 3 times 1 is 3. -18 divided by 3 is just -6. So -2/3 times 9 is -6. And then we just add 6 to both sides. And b equals 28. So my equation of a line that is parallel to this line but goes through this point is going to be y equals -2/3 x plus 28. Yeah, pretty cool. So like I said, tomorrow we'll do a little bit more application with perpendicular lines, and then we'll do some kind of cool problems that kind of mash up between these two. All right? You guys have an excellent day. I'll see you later.